All right, so question number 8, January 2021. This says, so January 2021, question number 8A says, the straight line graph x is equal to 5 minus 3y intersects the x-axis at P. So P is the x-intercept. P is the x-intercept and intersects the y-axis at Q. Q is the y-intercept. We're asked to determine the coordinates of P and Q. All right. If we wanted to, we could arrange it in the form. All right, let's do it anyway. We could arrange it in the form y is equal to mx plus c. We could. We didn't have to, but we can. So we have x is equal to 5 minus 3y. So 3y is equal to minus x plus 5. We're rearranging so as to make y the subject. So next, I'm going to divide the entire equation by 3. So divide the entire equation by 3. When I do, I'm going to end up with y is equal to minus 1/3 x. So the gradient is minus 1/3, and the y-intercept is 5 over 3, which is the same as saying 1 and 2/3. So Q, which is the y-intercept, remember, when an equation is in the form y is equal to mx plus c, c, the number at the end, is the y-intercept. So the y-intercept here is 5 over 3, which is 1 and 2/3. That's the y-intercept. And the x-coordinate of the y-intercept is 0. So Q is 0, 5 over 3, or 0, 1 and 2/3. That is Q, which is the y-intercept. So y-intercept. That's the y-intercept, 5 over 3. So 0, 5 over 3 is the coordinate of the y-intercept. What we need now is P. What we need now is P, which is the x-intercept. So the x-intercept. We probably can use this version of it. X is equal to 5 minus 3y. Same line. Now, the x-axis is the line y is equal to 0. So the y-coordinate is always 0. So I'm going to simply say when y is equal to 0, x would be equal to 5 minus 3 times 0. 3 times 0 is 0. 5 minus 0 is still 5. The x-coordinate is 5. The y-coordinate is 0. P is the point 5, 0. Next, we have to calculate the length of PQ. Now, the formula for the length of the line L is the square root of x2 minus x1 square plus y2 minus y1 square. If you have the y2 minus y1 first, it doesn't matter, you'll get the same answer. So L would be x2, which is what? 0, minus x1, which is 5, square, plus y2, which is what? 5 over 3, minus y1, which is 0, square. So this is the square root of 5 minus 5 square plus 5 over 3 square. So this is the square root of 25 plus 25 over 9 So this is the square root of 250. All right, I'm going ahead of myself. If I want, I could just put this in my calculator and press equal. So you don't have to go in. You can, if you have a smart enough calculator, which that's an issue now, someone who don't. So let me just go further. The LCM is 9. 1 into 9 goes 9. 9 times 25. This is 225. 9 into 9 is 1. 1 times 25 is 25. So this is the square root of 250 over 9. Put that in the calculator. Make sure when you put it in the calculator, you put brackets around it. Or else you might end up get something wrong. So the square root of 250 divide by 9. I don't think you actually need no bracket. You don't need no bracket for this one. All right, and the answer here is 5.27. This is 5.27 units. So the length of the line from P to Q is 5.27 units. So that's the coordinate geometry formula for the length of a line. Stay with me. Next, we're told that R is the midpoint of PQ. We're asked to determine the coordinates of R. So the coordinates of the midpoint of a line is x1 plus x2 over 2, comma, y1 plus y2 over 2. That's the formula. And you must remember this formula. So the first point is 5, 0. And the next point is what? 0, 5 over 3. So x1 is 5 plus x2, which is what? 0 over 2, comma, y1, which is what? 0 plus y2, which is 5 over, it's not 5 over 2, it's 5 over 3. 5 over 3 over what? 2. So R is 5 over 2, comma, 5 over 3 over 2. Now, 5 over 3 over 2 is 5 over 3 divided by 2, which is 5 over 3 times 1 over 2. This is 5 over 6. So my answer is R is the point 5 over 2, comma, 5 over 6. R is the point 5 over 2, 5 over 6. All right. B part of the question is relations and function. At least that's what it looks like. All right. And then C looks like we're going into something different. Here we're told that the functions f and g are defined as follows. The graph of f and g meet at points M and N. Determine the coordinates of the points M and N. All right, this man is really milking this question. All right, guys, here's what we're gonna use. So we have two lines. Y is equal to 5 minus x, and we have y is equal to x squared minus 2x minus 1. Now, what we're going to use to do this is, remember, we want the point of intersection of these two lines. We're going to use the fact that at the point of intersection, and this only occurs at the point of intersection y1 is equal to y2. This only occurs at the point of intersection. So at the point of intersection, the two y's are equal. So y for one of the graph is x squared minus 2x minus 1, and y for the next graph is 5 minus x. Now, y1 is equal to y2. This only occurs at the point of intersection of two graphs. That's the only time it occurs. Let's solve this quadratic equation. X squared minus 2x plus x minus 1 minus 5 is equal to 0. The first step in solving a quadratic equation is to ensure that one side of the equation is equal to 0. So now I have x squared minus x minus 6 is equal to 0. I need to factorize this. AC is 1 times minus 6, and this is minus 6. B is minus 1. I need two numbers. When I multiply them together, I get minus 6. When I add the same two numbers together, I get negative 1. So one of the numbers must be negative and one must be positive. And the sign of B is the sign of the larger number. The two numbers are minus 3 and positive 2. When you multiply them together, you get minus 6. When you add them together, you're going to get minus 1. So this is x squared. Use those two numbers to replace the middle term. Minus 3x plus 2x minus 6 is equal to 0. X is common. X minus 3 plus 2 is common. X minus 3 is equal to 0. So now we have what? X minus 3 is common. In the next bracket, x plus 2 is equal to 0. If you're multiplying two things and you're getting 0, it is either the first that is equal to 0 or the second that is equal to 0. So x is equal to 3 or x is equal to minus 2. Now, those are the values of x at the point of intersection. It is only at the point of intersection that y1 is equal to y2. So the value of x I'm getting here are the values of x at the point of intersection. So what I need now is the value of y. Now, what I'm going to do next is I'm going to get the linear equation. We have two equations, a linear and a quadratic. Y is equal to 5 minus x. When x is equal to 3, y is equal to 5 minus 3, which is 2. So 3, 2 is one of the points of intersection. If you want, you could say that that is M. Now, when x is equal to minus 2, y is equal to 5 minus 2, which is 5 plus 2. This is what? 7. So minus 2, 7 is the next point of intersection. I'm guessing we can then call that N. So these are the steps you would take to determine the point of intersection of two graphs. Using the fact that at the point of intersection, y1 is equal to y2. Guys, the C part of the question says, Monty is cycling at 12 meters per second. After 4.5 seconds, he starts to decelerate. And after a further 2.5 seconds, he stops. The speed time graph is shown below. We're to calculate the constant deceleration. Now, for a speed time graph, deceleration or acceleration is equal to the gradient. So this line here represents the deceleration. He was traveling at 12. So this is speed. He was traveling at 12. Then after a certain time, he starts to decelerate until his speed is what? 0. Now, as I said, it is the gradient of the speed time graph that is equal to acceleration. So let's get the gradient here. Let's use 2 points. You need 2 points to get a gradient. This is 4.5. Let me see if those are the best 2 points. Yep. This is 4.512. This is 7, 0. So the x coordinate is time, the y coordinate is speed. At the top, his speed was 12. At the bottom, his speed is 0. He has stopped. M, the gradient A, which is m, the gradient is equal to y2 minus y1 over x2 minus x1. y2, 0, minus y1, 12, over x2, 7, minus x1, 4.5. This is minus 12 over 4.5. Sorry, not 4.5, this is 2.5. Over 2.5, using my calculator. And this says 4.8. This is minus 4.8, and it's meters per second square. All right, so the negative there is indicating the deceleration. The negative there is indicating the deceleration. All right, so the deceleration is the gradient, which is what? Minus 4.8 meters per second square. Now it says Monty's average speed over the, what is Monty's average speed over the 7 seconds? So his journey was 7 seconds. Now, average speed is total distance over total time. Average speed is total distance over total time. Now, the total time we already know is 7 seconds. What we need now is the distance. Now, I think for the speed time graph, I think the area under the graph calculates distance. The speed time graph, I think the area under the graph calculates distance. So the graph itself, the area for the entire graph is a trapezium. The area for the entire graph is a trapezium. Up here, so is 4.5. Down here is 7, and the height is 12. So if I want to get the total distance, I just need to calculate the area under the graph. So the total distance is the area, which is equal to a half A plus B times H. So A would be here, this is A, this is B, and this is H, which is 12. So this is a half times 4, sorry, it's a half times up top 4.5 plus 7 times 12. So the total distance would be 6, because a half of 12 is 6. it would be 6 multiplied by 11.5 divided by 7. This will give you now is average speed for the entire journey. 6 times 11.5 divided by 7. And I'm seeing 9.86. 9.86, and this is meters per second. So is average speed? Average speed is total distance divided by total time. The total distance it traveled was 6 times 11.5. The total time is 7. When you divide, you get 9.86 meters per second.